Welcome, traveler. You found the slumbering cosmos. Tonight we are going to ask the oldest and largest question there is. The question people have asked, looking up at the stars, since the very first human being wondered what those lights were. The question that has never quite been answered, and maybe the most important question we will ever ask. Are we alone? In all this vastness, 100 billion stars in our galaxy alone, and 100 billion galaxies beyond it, more worlds than there are grains of sand on every beach on Earth. Is there anyone else? Anywhere? Any other living thing on any other world, looking up at its own night sky, wondering the very same thing about us? And I want to promise you, gently, right at the start, tonight is not about answering that question. No one can answer it yet. Tonight is about wondering it, softly, calmly, the way you might turn a beautiful and mysterious stone over and over in your hands, not to solve it, but simply to feel its weight and its strangeness and its beauty. We're going to visit the places where life might be hiding, right here in our own solar system and out among the distant stars. We're going to hold the great question up to the light, and we're going to find that, however it is answered, there is something deeply peaceful in the asking. So there is nothing to solve tonight, nothing to decide, only a quiet, wandering journey through all the places where we are looking and hoping and listening. And wherever it leads, you are safe and warm and exactly where you belong. So settle in. Set the day down, all of it, the finished and the unfinished. None of it needs you tonight. It will keep until morning, and you will meet it then, rested. For now, there's only this quiet wondering, and there is nothing to do but drift and listen, and let the great question carry you gently along. Let the bed take your whole weight, all of it, so that you are holding nothing up, bracing against nothing. Feel your shoulders slide down, away from your ears. Feel your hands fall open, the fingers softening. Let your jaw come loose, your brow smooth, the small tightnesses around your eyes let go. And let a slow warmth begin at the crown of your head and move down through you, through your face, your chest, your arms, down through your legs to your feet, carrying the whole day out of you as it goes down and away into the dark, where it can no longer reach you. And let your breathing slow, all on its own. Don't force it. Just notice it, the soft rise, the slower fall. And let each breath out grow a little longer, a little gentler than the one before. Take one slow breath in and let it go all the way out. Let's go looking for life among the stars. Before we go looking for life, let us ask gently what life even needs. For if we're to search for it, it helps to know what we are searching for. Life, as far as we understand it, is surprisingly modest in its requirements. It seems to need only a few things. It needs some kind of liquid, most likely water, that gentle, common substance in which the chemistry of life can mix and flow and combine. It needs a source of energy, the light of a star, perhaps, or the warmth rising from a world's own interior. It needs certain common building blocks, carbon and hydrogen and oxygen and nitrogen, the ordinary atoms that make up so much of everything. And more than anything, it seems to need time. Long, patient stretches of time in which slow chemistry can become, somehow, across the ages, the first stirrings of something alive. And here is the quietly astonishing thing. None of these ingredients is rare. Water is one of the most common substances in the universe. Carbon and oxygen and nitrogen are forged in the hearts of stars and scattered everywhere. Starlight is abundant beyond counting. In time, the universe has had nearly 14 billion years of it, and will have almost endlessly more. The ingredients for life, as best we understand them, are not exotic, not precious, not hard to find. They're spread throughout the cosmos, on countless worlds, in endless supply, which makes the great question all the sharper and all the stranger. If the ingredients are everywhere, then where is everybody? Perhaps life is common, and the universe is quietly teeming, and we simply have not yet learned to see it. Or perhaps the leap from ingredients to life, that mysterious first spark when chemistry first became alive, is so rare, so difficult, so nearly impossible, that it has happened only here, only once, only us. We do not know. That is the beautiful, open heart of the mystery. And tonight, we get to explore both possibilities gently, one world at a time. Let us begin close to home with a small red world that may once have been alive. The first place we look for life is Mars, the rusty red world, forth from the sun, the planet that has haunted human imagination longer than any other. Today, Mars is cold and dry and still. A frozen desert, its thin air unbreathable, its surface swept by dust, its rivers and seas long gone. If you stood there now, you would find no living thing, no green, no stir of anything, only rose-colored sand and silence under a butterscotch sky. But Mars was not always like this, and this is what draws us to it again and again. Billions of years ago, when the solar system was young, Mars was a warmer, wetter world. We can see the evidence written across its surface even now, the dry beds of ancient rivers winding across the desert, the basins of vanished lakes, the rounded pebbles that only running water could have made, the clays that only form in the presence of water. Long ago, on Mars, rain fell, rivers ran, lakes and perhaps whole seas lay under an open sky. For hundreds of millions of years, Mars was a world with liquid water on its surface, one of the very conditions we believe life needs. And so the question hangs there in the cold Martian air, in all those warm, wet ages on that younger, gentler Mars. Did anything ever stir to life? Did something small and simple ever arise in those ancient lakes, as it did in Earth's, at just about the same time? And if it did, is any trace of it still there, hidden in the rocks, or perhaps still clinging to life in some warm, damp refuge deep underground, where a little liquid water may linger even now? And imagine that younger Mars, for a moment, as we drift above it, for it is a gentle thing to picture, a warmer world with a bluer sky, rivers winding silver across rust-red plains, rain falling softly on the shores of open lakes, the whole planet quietly alive with water and weather 3.5 billion years ago, at the very same time that life was first stirring in the seas of the young Earth next door. Two worlds side by side, both warm, both wet, both washed by the same young Sunday. On one of them, life took hold and grew and became everything, became forests and whales and cities and you. And on the other, we simply do not know. Perhaps the same spark caught briefly in some warm Martian pool and then flickered out as the world grew cold. Perhaps it never caught at all. Two nearly identical beginnings, and only one of them that we know of ever awoke. We have sent our patient robots to look. They roll slowly across the red deserts. These little machines drilling into ancient rock, sniffing the thin air, searching for any faint chemical whisper that life was ever there. They have found the ingredients. They have found the ancient water. They have not yet found life, but they have not ruled it out. And the search goes on gently on a quiet red world for any sign that we were once not alone, even here, even next door. Let the little rovers keep their patient watch on Mars. We drift outward now to a moon with an ocean hidden beneath its ice. The next place we look is one of the most hopeful places in all the solar system. And it is not a planet at all, but a moon. Europa, one of the great moons of Jupiter. From the outside, Europa looks unremarkable, even forbidding, a small, pale, frozen world wrapped in a smooth shell of ice, crisscrossed with strange reddish cracks, drifting far from the sun in the cold outer solar system. Nothing about its frozen surface suggests life. But beneath that shell of ice, and this is what makes Europa one of the most exciting worlds we know, there's thought to be an ocean. A real ocean of liquid, salty water, perhaps 60 or 100 kilometers deep, hidden beneath the frozen crust, kept liquid across billions of years, not by the distant sun, but by the constant, gentle flexing of Jupiter's enormous gravity, which needs the little moon and warms its interior from within. And that hidden ocean, if it truly exists as we believe, holds more water than all the oceans of the earth combined. Twice over. Think of it, a vast, dark, warm, salty sea 60 kilometers beneath a shell of ice on a small moon far from the sun, an ocean that has been there liquid and undisturbed for billions of years. On Earth, everywhere we find water, we find life. In our deepest ocean trenches, in the crushing dark where no sunlight ever reaches, life thrives around warm volcanic vents on the seafloor. And there may be such vents on the floor of Europa's hidden ocean too, warm cracks in the rock, seeping heat and minerals into that dark sea, exactly the kind of place where life on Earth may first have begun. And picture that hidden sea for a moment as we hover above the frozen moon, above the thick shell of ice, kilometers deep, sealing everything in eternal dark, and below, a vast black ocean, warm and salty and still, where no light has ever shone, where no star has ever been seen. An ocean that has lain there undisturbed for billions of years in a silence and a darkness more complete than anything on Earth. If life swims there, it has never known the sun. It has never seen the sky. It lives entirely by the warmth rising from the rocks below in a perfect and permanent night. And it would not feel this as darkness or as loss. It would simply be its home, the only world it has ever known, warm and dark and quiet, exactly as it should be. There is something in that image that touches the very edge of peace. A whole living world, perhaps wrapped in warm, dark water, needing no light, no sky, no sun, held safely beneath the ice, going gently about its ancient life in the deepest quiet there is. We do not know if anything swims in Europa's ocean. Perhaps it is barren. Perhaps in that warm, dark sea, something stirs. We're building spacecraft, even now, to go and look, to fly close and study that ice, and one day, perhaps, to peer beneath it. A hidden ocean on a frozen moon, holding its secret patiently in the dark. Let it drift on around its giant, keeping its long quiet. We travel to a smaller moon still, one that is spraying its ocean into space. If Europa hides its ocean, our next world offers up its own, flinging it into space for anyone to see. This is Enceladus, a small, bright, icy moon of Saturn, and it may be the most astonishing little world in the solar system. Enceladus is tiny. You could fit it comfortably within the length of a single country on Earth. It is wrapped, like Europa, in a shell of ice, and it too is thought to hold a hidden ocean of liquid water beneath its frozen surface. But Enceladus does something extraordinary, something that took our breath away when we first saw it. From great cracks near its south pole, it sprays that hidden ocean directly into space. Enormous plumes and geysers of water vapor and ice, jetting hundreds of kilometers up from the surface, feeding a faint ring around Saturn with the frozen mist of a moon's own sea. And here is the wonderful part. When our spacecraft Cassini flew through those plumes, actually flew through the spray of an alien ocean and tasted it, it found more than just water. It found salts, the same kind dissolved in Earth seas. It found organic molecules, the carbon-based building blocks that life is made from. And it found signs of warmth, of chemical activity at the bottom of that hidden ocean, evidence of warm vents on the seafloor, seeping energy and minerals into the dark water, exactly the conditions where life on Earth may have begun. So on this one tiny moon, far out by Saturn, we have found nearly everything life needs, all in one place. Liquid water, warmth, the right chemistry, and the energy to drive it. Whether life has actually arisen there, we do not know. But Enceladus took a sample of its own hidden sea and threw it up into the sunlight for us to catch, as if the little moon were trying, gently, to show us what it holds. A tiny world spraying its secret ocean into space. There are few things in all the solar system more wonderful or more full of quiet promise. And there is a lesson in Enceladus that reaches beyond the search for life. Here is a moon so small we once dismissed it entirely, a little frozen speck, far from the sun, that no one imagined could hold anything of interest. And it turned out to conceal a warm ocean and organic chemistry, and very nearly everything life needs hidden beneath its quiet ice. It reminds us how easily we underestimate the small, the cold, the overlooked, how the most unremarkable seeming things can hold entire hidden worlds within them. The universe keeps its treasures in unexpected places, and perhaps that is worth remembering gently as you lie here in the quiet dark, that even the smallest and stillest things can hold, hidden within, something warm and living and precious. Let the little geysers of Enceladus glitter in Saturn's light. We drift on to a world with seas of an entirely different kind. Our next world is one of the strangest and most beautiful places we know. A world with rivers and rain and seas, and yet utterly unlike the Earth. This is Titan, the great moon of Saturn, the only moon in the solar system with a thick atmosphere of its own. Titan is a hazy, golden world wrapped in a dense orange atmosphere, so thick you cannot see its surface from above. And beneath that haze, it is the one other place in the entire solar system where we know that liquid pools on the surface, where there are actual rivers and lakes and great seas under an open sky, complete with clouds and rain and shorelines. But the rivers of Titan are not made of water. Titan is far too cold for that. So cold that water there is frozen as hard as rock. Instead, its rivers and seas are made of liquid methane and ethane, of natural gas, kept liquid by the intense cold. It rains methane on Titan. Rivers of methane carve valleys through hills of ice. Great methane seas, hundreds of kilometers wide, lap against frozen shores under an orange sky. It is a complete and familiar landscape. Rain, rivers, lakes, seas, built entirely from utterly unfamiliar materials. And this raises one of the most tantalizing questions in all the search for life. Life on Earth is built around liquid water. But might life, some strange, alien kind of life we can barely imagine, be possible in liquid methane instead? Could there be, in Titan's cold seas, a chemistry we have never seen, a life not built on entirely different molecules, thriving in a place that to us would be unimaginably cold and toxic? We do not know. It would be life so different from ours that we might struggle even to recognize it. But Titan reminds us of something important and humbling, that we have only one example of life, our own, and the universe may be far more inventive than our single example can teach us. And there is a strange, dreamlike beauty to Titan that is worth resting in for a moment. It is, in some ways, the most Earth-like place we have ever found. Not because it is warm or wet with water, but because it is the one other world with weather, with a real cycle of evaporation and cloud and rain and flowing rivers and standing seas, just like ours. If you could stand on its shore, wrapped against the terrible cold, you would see a landscape hauntingly familiar and utterly alien at once. Gentle waves lapping a dark beach, rivers winding down from misty hills, rain falling softly from an orange sky, all of it in slow motion. For in Titan's low gravity and thick air, the raindrops fall gently, drifting down like slow snow, and the waves roll in lazily across the methane seas. A whole familiar world playing out in dreamlike slowness beneath a sky of gold. A world of methane rain and frozen shores under a golden sky. Whether anything stirs in its cold seas, we cannot say, but it teaches us to keep our imaginations open and our sense of the possible wide. Let the methane rain fall softly on Titan. We leave our own solar system now and go out among the other stars. We have searched our own solar system, Mars, Europa, Enceladus, Titan, and found everywhere the ingredients and the possibility of life, but not so far life itself. Now we go further, out among the other stars, where the true numbers begin. For most of human history, we did not know if other stars even had planets. We hoped, we imagined, but we did not know. And then, only about 30 years ago, we found the first one, and then another, and another, and now we know, beyond any doubt, that planets are not rare at all. They are everywhere. Nearly every star you see in the night sky, we now believe, has planets of its own. Our galaxy alone holds not billions, but likely hundreds of billions of planets. More worlds than there are stars. And among all those countless worlds, we search especially for a particular kind, the ones that orbit in what astronomers gently call the habitable zone. The Goldilocks zone, that comfortable band around a star, neither too close nor too far, where a world would be neither too hot nor too cold, where the temperature would be just right for liquid water to pool on its surface, as it does on Earth. Not scorching like the innermost worlds, not frozen like the distant ones, but temperate, gentle, just right. And we have found them. Rocky worlds, roughly the size of the Earth, orbiting in the habitable zones of their stars, where liquid water could, in principle, exist. Not just a few of them, many. When astronomers do the arithmetic, adding up all the stars and all their planets, and estimating how many might sit in that gentle tempered band, the numbers become staggering. There may be billions of potentially habitable, roughly Earth-like worlds in our galaxy alone. Billions of places where the conditions might be right. Billions of possible Earths. And try, gently, to picture even a few of them. A world a little larger than Earth, circling a warm orange star, its oceans lapping at unknown shores under a sky no human has ever seen. A world with two suns casting double shadows across its plains. A world of endless ocean wrapped in water from pole to pole with no land at all. A world circling a small red star, bathed in soft crimson light, where the plants, if there are plants, might be black instead of green to catch that dimmer sun. Billions of worlds, each one real, each one out there right now, turning under its own star, most of them never to be seen by any human eye, and any one of them, or none of them, or a great many of them, might hold something alive. Billions. Let that number settle over you, softly, in the dark. Not one other possible Earth. Not a handful. Billions of them, scattered through our single galaxy, and 100 billion galaxies beyond. The universe, it turns out, is not stingy with worlds where life might live. It is extraordinarily, almost recklessly, generous. Let's try, gently, to reckon with what that generosity might mean. With so many worlds, and so many of them possibly suitable, surely, the universe must be full of life. This was the reasoning of a scientist named Frank Drake, who, more than 60 years ago, tried to think the question through carefully and turned it into something almost like a gentle piece of arithmetic. He reasoned like this. Start with the number of stars. Multiply by the fraction that have planets, which we now know is most of them. Multiply by the number of those planets that might be suitable for life, then by the fraction where life actually arises, then by the fraction where that life becomes intelligent, then by the fraction that might send signals out into space, and finally by how long such civilizations might last. Multiply all of that together, and you get an estimate, rough and deeply uncertain, of how many other communicating civilizations might be out there in our galaxy right now. It is a beautiful way to think because it breaks the impossible question into smaller, more approachable pieces. But it has a humbling honesty at its heart. For many of those fractions, we simply do not know the answer. We know there are many stars and many planets and many that might be suitable, but we do not know how often life actually arises. We do not know how often it becomes intelligent. We do not know how long civilizations last. And so, depending on what numbers you believe, the equation can tell you that the galaxy is teeming with thousands of civilizations, or that we are most likely entirely alone. The same simple equation, the same honest arithmetic, can give both answers. And that, more than anything, is the true measure of how little we know and how open the question remains. We're not close to answering it. We're only beginning to learn how to ask it well. And there's a strange comfort in that, too, in standing before a question so vast that our best minds can only frame it, not solve it. Some mysteries are meant to be lived alongside, not closed. Let's look now at the strangest part of the puzzle of all. Here is the deepest puzzle in the whole question, and it has a name. It is called the Fermi paradox, after the physicist Enrico Fermi, who is said to have summed it up over lunch one day in a single simple question: where is everybody? The paradox is this: the universe is old, nearly 14 billion years. Our galaxy is full of stars far older than our sun, with planets far older than the Earth, worlds that had billions of years head start on us. If life is common, and if even a tiny fraction of it becomes intelligent, and if even a few of those civilizations spread out among the stars, then the galaxy should have been visited, colonized, filled with the signs of life, long, long before humans ever appeared. By all rights, the sky should be busy. We should see them. We should hear them. The evidence of others should be everywhere. And yet, when we look, we find silence. We have listened for decades with great radio telescopes for any signal, any whisper, any sign of another civilization among the stars. We have searched the light of distant worlds for the chemical traces of life. And so far, we have found nothing. No signals, no structures, no unmistakable sign that anyone else is out there at all. The universe, as far as we can yet tell, is quiet. Where is everybody? It is one of the great open questions of our age, and no one knows the answer. But please hear me gently as you drift towards sleep. The silence is not necessarily a sad thing or a frightening thing. There are many possible reasons for it, and most of them are not lonely at all. Let me tell you a few of them, softly, because I think you will find them more comforting than the silence itself. Why is the universe so quiet? No one knows. But there are many gentle possibilities, and I would like to leave you with them because each one is, in its own way, a kind of peace. Perhaps life is simply rare. Perhaps that first spark, the leap from lifeless chemistry to the first living thing, is so difficult, so nearly miraculous, that it has happened only a handful of times in the whole galaxy, or perhaps only once. If that is so, then we're not surrounded by silence because something went wrong. We are surrounded by silence because we are precious, because life is a rare and beautiful thing, and we are among the first or the few to carry it. That is not a lonely thought. It is a tender one, or perhaps we are simply early. The universe is still young. The great age of stars has only just begun and will last for trillions of years more. Perhaps we have arrived near the dawn of things, before most other life has had the chance to arise. Perhaps the galaxy will one day be full of voices, and we are simply among the very first to speak in a conversation that has barely begun. Or perhaps they are out there quietly, and we simply cannot yet hear them, too far away, or speaking in ways we have not learned to listen for, or content as we might one day be, to live their lives in peace without shouting across the stars. The silence may not be emptiness. It may only be distance and patience and our own young ears, not yet able to hear the quiet conversation of the cosmos. And there is one more possibility, perhaps the gentlest of all, and I offer it to you softly. Perhaps the reason we have not heard from anyone is simply that the universe is very, very large and very, very young, and we have been listening for only a single human lifetime, with instruments we have had for only a few decades, pointed at only a tiny fraction of the sky. Imagine standing on a shore at night, listening for the voice of someone across a vast dark ocean, and giving up after a single minute because you heard nothing. The cosmic ocean is unthinkably wide. We have been listening for barely a moment. It would be far stranger, really, if we had already heard something than that we have not. The silence so far is exactly what we should expect. Not because no one is there, but because the sea is so wide and we have only just begun to listen. We do not know which of these is true. Perhaps none of them. Perhaps all. But notice that every one of them is gentle. Whether we are precious or early or simply not yet listening well enough, none of these is a cause for fear. The great silence, held the right way, is not a void. It is a question still beautifully open, at a universe still full of possibility, and a mystery that asks nothing of us tonight but to wonder at it softly and rest. Let's come home now and hold the whole question one last time. Let us come home now from the far worlds and the great silence, back to this one small planet and this one warm bed. And you, we have looked tonight in so many places. The dry riverbeds of Mars, the hidden ocean of Europa, the spraying geysers of Enceladus, the methane seas of Titan, and out among billions of stars, billions of possible Earths, and the deep and beautiful silence that surrounds them all. And after all that looking, the great question remains exactly as open as it was when we began. Are we alone? We still do not know. But here is what I want you to carry down into sleep, and it is the most comforting thing of all. because it is true whichever way the question is finally answered. If we are alone, if in all this vastness life arose only here, only once, only us, then you are part of something almost unimaginably precious. A single flame of life and awareness, lit against the whole dark cosmos, rare beyond measure. And if we are not alone, if the universe is quietly full of life, of other oceans stirring, other minds wondering, other worlds where someone is lying in the dark looking up, then you are part of a great and living cosmos, a member of a family of life spread across the stars, never truly alone at all. Either way, you win. Either way, it is beautiful. Either way, there is nothing to fear and everything to wonder at. Whether we are the universe's rarest treasure or one small note in its great living chorus, either way, you belong here and you matter, and the fact that you exist at all, that the universe has in you, become able to look up and ask whether it is alone. That is a wonder greater than any answer. And notice gently one last wonder before you sleep. In all this vast search across Mars and Europa and Enceladus and Titan, across billions of distant worlds and the great cosmic silence, there's one place, and so far only one, where we know beyond any doubt that the universe came alive. This one, here, the world you are lying on. Of all the countless worlds we have looked at, this is the single confirmed miracle. The one place where dead chemistry somehow, for billion years ago, stirred and woke and became alive and kept becoming and became forests and oceans full of fish and birds in the morning and eventually became you, a piece of the universe that can look up at its own stars and wonder whether it is alone. Whatever else is or is not out there, that already happened here. The impossible thing already occurred right where you are. So let the great question rest tonight. It will keep. It is kept for as long as there have been eyes to look up, and it will keep until morning and long after. You do not have to answer it. You only have to lie here, small and warm and alive, on this one world where we know for certain that life exists because you are here breathing in the dark, a piece of the living universe come to rest. Close your eyes now, if they're not already closed. Breathe in slowly and out even more slowly. Whether we are alone or not, you are here and you are alive and you are a wonder. And tonight, that is more than enough. The cosmos is slumbering, and so are you. Good night, traveler. Sleep well, small light in the great dark.